ball lightning is an unexplained atmospheric electrical phenomenon. The term refers to reports of luminous, spherical objects which vary in diameter from pea-sized to several meters. It is usually associated with thunderstorms, but lasts considerably longer than the split-second flash of a lightning bolt. Many early reports say that the ball eventually explodes, sometimes with fatal consequences, leaving behind the odor of sulfur. Many scientific hypotheses about ball lightning have been proposed over the centuries. In January 2014, spectrography data that was captured by chance lent support to the vaporized silicon hypothesis. Until the 1960s, most scientists argued that ball lightning was not a real phenomenon, despite numerous sightings throughout the world. Laboratory experiments can produce effects that are visually similar to reports of ball lightning, but whether these are related to the natural phenomenon remains unclear. Scientific data on natural ball lightning are scarce, owing to its infrequency and unpredictability. The presumption of its existence is based on reported public sightings, and has therefore produced somewhat inconsistent findings. Given inconsistencies and lack of reliable data, the true nature of ball lightning is still unknown. The first ever optical spectrum of what appears to have been a ball lightning event was published in January 2014 and included a video at high frame rate. Historical accounts: it has been suggested that ball lightning could be the source of the legends that describe luminous balls, such as the Mapuk-Angamayan of mythology. In a 1960 study, 5% of the population of the Earth reported having witnessed ball lightning. Another study analyzed reports of 10,000 cases. Mloba copyright de Tressan, in mythology compared with history, or, the fables of the ancients elucidated from historical records. During a storm which endangered the ship Argo, fires were seen to play round the heads of the Tindarides, and the instant after the storm ceased. From that time, those fires which frequently appear on the surface of the ocean were called the fire of Castor and Pollux. When two were seen at the same time, it announced the return of calm. When only one, it was the presage of a dreadful storm. This species of fire is frequently seen by sailors, and is a species of ignis fatuus. This account, however, shares more commonalities with the St. Elmo's fire phenomenon. Wells, Somerset. It was reported in John Stow's Annals that in December 1596 during a church sermon at Wells in Somerset, England, there entered in at the west window of the church a dark unproportioned thing about the bigness of a football, and went along the wall on the pulpit side. And suddenly it seemed to break with no less sound than if 100 cannons had been discharged at once. And therewithal came a most violent storm and tempest of lightning and thunder as if the church had been full of fire. No one was killed, though many were thrown to the ground. Many were marked in their garments with figures of crosses and stars. Some of the stonework broke down, and the wires and irons in the clock melted, but none of the woodwork was burned. The Great Thunderstorm of Widdecombe in the Muir. Another early description was reported during the Great Thunderstorm at a church in Widdecombe in the Muir, Devon, in England, on October 21, 1638. 4 people died and approximately 60 were injured when, during a severe storm, an 8-foot ball of fire was described as striking and entering the church, having nearly destroyed it. Large stones from the church walls were hurled into the ground and through large wooden beams. The ball of fire allegedly smashed the pews and many windows, and filled the church with a foul sulphurous odor and dark, thick smoke. The ball of fire reportedly divided into 2 segments, one exiting through a window by smashing it open, the other disappearing somewhere inside the church. The explanation at the time, because of the fire and sulfur smell, was that the ball of fire was the devil, or the flames of hell. Later, some blamed the entire incident on 2 people who had been playing cards in the pew during the sermon, thereby incurring God's wrath. The Catherine and Mary. In December 1726 a number of British newspapers printed an extract of a letter from John Howell of the sloop Catherine and Mary. As we were coming through a Euro unregistered trademark the Gulf of Florida on the 29th of August, a large ball of fire fell from the element and split our mast in 10,000 pieces, if it were possible. Split our main beam, also 3 planks of the side, underwater, and 3 of the deck. Killed 1 man, another had his hand carried off, sick, and had it not been for the violent rains, our sails would have been of a blast of fire. The Montague, one particularly large example, was reported on the authority of Dr. Gregory in 1749. Admiral Chambers on board the Montague, November 4, 1749, was taking an observation just before noon. He observed a large ball of blue fire about 3 miles distant from them. They immediately lowered their topsails, but it came up so fast upon them, that, before they could raise the main tack, they observed the ball rise almost perpendicularly, and not above 40 or 50 yards from the main chains when it went off with an explosion, as great as if 100 cannons had been discharged at the same time, leaving behind it a strong sulphurous smell. By this explosion the main topmast was shattered into pieces and the mainmast went down to the keel. 5 men were knocked down and one of them much bruised. Just before the explosion, the ball seemed to be the size of a large millstone. Georg Richman, a 1753 report depicts ball lightning as being lethal when Professor Georg Richman of St. Petersburg, Russia, created a kite-flying apparatus similar to Benjamin Franklin's proposal a year earlier. Richman was attending a meeting of the Academy of Sciences when he heard thunder and ran home with his engraver to capture the event for posterity. While the experiment was underway, ball lightning appeared and traveled down the string, struck Richman's forehead and killed him. The ball left a red spot on Richman's forehead, his shoes were blown open, and his clothing was singed. His engraver was knocked unconscious. The door frame of the room was split and the door was torn from its hinges. HMS Warren Hastings, an English journal, reported that during an 1809 storm, 3 balls of fire appeared and attacked the British ship HMS Warren Hastings. The crew watched one ball descend, killing a man on deck and setting the main mast on fire. A crewman went out to retrieve the fallen body and was struck by a second ball, which knocked him back and left him with mild burns. A third man was killed by contact with the third ball. Crew members reported a persistent, sickening sulfur smell afterward. Ebenezer Cobham Brewer, in his 1864 U.S. edition of A Guide to the Scientific Knowledge of Things Familiar, discussed globular lightning. He describes it as slow-moving balls of fire or explosive gas that sometimes fall to the earth or run along the ground during a thunderstorm. He said that the balls sometimes split into smaller balls and may explode like a cannon. Wilfred de Fonville, in his book Thunder and Lightning, translated into English in 1875, French science writer Wilfred de Fonville wrote that there had been about 150 reports of globular lightning. Globular lightning seems to be particularly attracted to metals. Thus it will seek the railings of balconies, or else water or gas pipes, etc. It has no peculiar tint of its own but will appear of any color as the case may be. At Coethen in the Duchy of Anhalt it appeared green. M. Vice President of the Geological Society of Paris, saw a ball of lightning descend slowly from the sky along the bark of a poplar tree. As soon as it touched the earth it bounced up again, and disappeared without exploding. On 10 September 1845 a ball of lightning entered the kitchen of a house in the village of Salagnac in the valley of Corrèze. This ball rolled across without doing any harm to 2 women and a young man who were here. But on getting into an adjoining stable it exploded and killed a pig which happened to be shut up there, and which, knowing nothing about the wonders of thunder and lightning, dared to smell it in the most rude and unbecoming manner. The motion of such balls is far from being very rapid. They have even been observed occasionally to pause in their course, but they are not the less destructive for all that. A ball of lightning which entered the church of Stralsund, on exploding, projected a number of balls which exploded in their turn like shells. Tsar Nicholas II, the last emperor of Russia, reported witnessing what he called a fiery ball while in the company of his grandfather, Tsar Alexander II. Once my parents were away, recounted the Tsar, and I was at the all-night vigil with my grandfather in the small church in Alexandria. During the service there was a powerful thunderstorm, streaks of lightning flashed one after the other, and it seemed as if the peals of thunder would shake even the church and the whole world to its foundations. Suddenly it became quite dark, a blast of wind from the open door blew out the flame of the candles which were lit in front of the iconostasis, there was a long clap of thunder, louder than before, and I suddenly saw a fiery ball flying from the window straight towards the head of the Emperor. The ball whirled around the floor, then past the chandelier and flew out through the door into the park. My heart froze. I glanced at my grandfather his face was completely calm. He crossed himself just as calmly as he had when the fiery ball had flown near us, and I felt that it was unseemly and not courageous to be frightened as I was. I felt that one had only to look at what was happening and believe in the mercy of God, as he, my grandfather, did. After the ball had passed through the whole church, and suddenly gone out through the door, I again looked at my grandfather. A faint smile was on his face, and he nodded his head at me. My panic disappeared, and from that time I had no more fear of storms. Aleister Crowley, British occultist Aleister Crowley reported witnessing what he referred to as globular electricity during a thunderstorm on Lake Pasquaney in New Hampshire in 1916. He was sheltered in a small cottage when he noticed, with what I can only describe as calm amazement, that a dazzling globe of electric fire, apparently between 6 and 12 inches in diameter, was stationary about 6 inches below and to the right of my right knee. As I looked at it, it exploded with a sharp report quite impossible to confuse with the continuous turmoil of the lightning, thunder and hail, or that of the lashed water and smashed wood which was creating a pandemonium outside the cottage. I felt a very slight shock in the middle of my right hand, which was closer to the globe than any other part of my body. R.C. Genuson, of the Electronics Laboratory at the University of Kent, described his own observation of ball lightning. I was seated near the front of the passenger cabin of an all-metal airliner on a late-night flight from New York to Washington. The aircraft encountered an electrical storm during which it was enveloped in a sudden bright and loud electrical discharge. Some seconds after this a glowing sphere a little more than 20 centimeters in diameter emerged from the pilot's cabin and passed down the aisle of the aircraft approximately 50 cm from me, maintaining the same height and course for the whole distance over which it could be observed. Other accounts. On April 30, 1877, a ball of lightning entered the Golden Temple at Amritsar, India, and exited through a side door. Several people observed the ball, and the incident is inscribed on the front wall of Darshani Diodi. On November 22, 1894, an unusually prolonged instance of natural ball lightning occurred in Golden, Colorado, which suggests it could be artificially induced from the atmosphere. The Golden Globe newspaper reported, "A beautiful yet strange phenomenon was seen in this city on last Monday night. The wind was high and the air seemed to be full of electricity. In front of, above and around the new Hall of Engineering of the School of Mines, balls of fire played tag for half an hour, to the wonder and amazement of all who saw the display. In this building is situated the dynamos and electrical apparatus of perhaps the finest electrical plant of its size in the state. There was probably a visiting delegation from the clouds, to the captives of the dynamos on last Monday night, and they certainly had a fine visit and a roistering game of romp." In July 1907 the Cape Naturalist Lighthouse in Western Australia was hit by ball lightning. Lighthouse keeper Patrick Baird was in the tower at the time and was knocked unconscious. His daughter Ethel recorded the event. An early fictional reference to ball lightning appears in a children's book set in the 19th century by Laura Ingalls Wilder. The books are considered historical fiction, but the author always insisted they were descriptive of actual events in her life. In Wilder's description, 3 separate balls of lightning appeared during a winter blizzard near a cast-iron stove in the family's kitchen. They are described as appearing near the stovepipe, then rolling across the floor, only to disappear as the mother chases them with a willow branch broom. Pilots in World War II described an unusual phenomenon for which ball lightning has been suggested as an explanation. The pilot saw small balls of light moving in strange trajectories, which came to be referred to as Foo Fighters. Submariners in WWII gave the most frequent and consistent accounts of small ball lightning in the confined submarine atmosphere. There are repeated accounts of inadvertent production of floating explosive balls when the battery banks were switched in or out, especially if mis-switched or when the highly inductive electrical motors were misconnected or disconnected. An attempt later to duplicate those balls with a surplus submarine battery resulted in several failures and an explosion. On August 6, 1944, a ball of lightning went through a closed window in Uppsala, Sweden, leaving a circular hole about 5 cm in diameter. The incident was witnessed by residents in the area, and was recorded by a lightning strike tracking system on the Division for Electricity and Lightning Research at Uppsala University. In 1954, Demokos Tör, a physicist, observed a lightning strike during a heavy thunderstorm. A single bush was flattened in the wind. Some seconds later, a speedy rotating ring appeared in the shape of a wreath. The ring was about 5 m away from the lightning impact point. The ring's plane was perpendicular to the ground and in full view of the observer. The outer inner diameters were about 60/30 cm. The ring rotated quickly about 80 cm above the ground. It was composed of wet leaves and dirt and rotated counterclockwise. After seconds, the ring became self-illuminated, turning increasingly red, then orange, yellow and finally white. The ring at the outside was similar to a sparkler. In spite of the rain, many electrical high-voltage discharges could be seen. After some seconds, the ring suddenly disappeared and simultaneously the ball lightning appeared in the middle. Initially, the ball had only one tail and it rotated in the same direction as the ring. It was homogeneous and showed no transparency. In the first moment, the ball hovered motionless, but then began to move forward on the same line with a constant speed of about 1 ams. It was stable and traveled at the same height in spite of the heavy rain and strong wind. After moving about 10 am, it suddenly disappeared without any noise. On July 10, 2011, during a powerful thunderstorm, a ball of light with a 2-meter tail went through a window to the control room of local emergency services in Liberec, Czech Republic. The ball bounced from window to the ceiling, then to the floor and back to the ceiling, where it rolled along it for 2 or 3 meters. Then it dropped to the floor and disappeared. The staff present in the control room were frightened, smelled electricity and burned cables and thought something was burning. The computers froze and all communications equipment was knocked out for the night until restored by technicians. Aside from damages caused by disrupting equipment, only one computer monitor was destroyed. Characteristics. Descriptions of ball lightning vary widely. It has been described as moving up and down, sideways or in unpredictable trajectories, hovering and moving with or against the wind. Attracted to, unaffected by, or repelled from buildings, people, cars and other objects. Some accounts describe it as moving through solid masses of wood or metal without effect, while others describe it as destructive and melting or burning those substances. Its appearance has also been linked to power lines as well as during thunderstorms and also calm weather. Ball lightning has been described as transparent, translucent, multicolored, evenly lit, radiating flames, filaments or sparks, with shapes that vary between spheres, ovals, teardrops, rods, or discs. Ball lightning is often erroneously identified as St. Elmo's fire. They are separate and distinct phenomena. The balls have been reported to disperse in many different ways, such as suddenly vanishing, gradually dissipating, absorption into an object, popping, exploding loudly, or even exploding with force, which is sometimes reported as damaging. Accounts also vary on their alleged danger to humans, from lethal to harmless. A review of the available literature published in 1972 identified the properties of atypical ball lightning. Whilst cautioning against over-reliance on eyewitness accounts, they frequently appear almost simultaneously with cloud-to-ground lightning discharge. They are generally spherical or pear-shaped with fuzzy edges. Their diameters range from 1 to 100 cm, most commonly 10 to 20 cm. Their brightness corresponds to roughly that of a domestic lamp, so they can be seen clearly in daylight. A wide range of colors has been observed, red, orange, and yellow being the most common. The lifetime of each event is from 1 second to over a minute, with the brightness remaining fairly constant during that time. They tend to move, most often in a horizontal direction at a few meters per second, but may also move vertically, remain stationary or wander erratically. Many are described as having rotational motion. It is rare that observers report the sensation of heat, although in some cases the disappearance of the ball is accompanied by the liberation of heat. Some display an affinity for metal objects and may move along conductors such as wires or metal fences. Some appear within buildings passing through closed doors and windows. Some have appeared within metal aircraft and have entered and left without causing damage. The disappearance of a ball is generally rapid and may be either silent or explosive. Odors resembling ozone, burning sulfur, or nitrogen oxides are often reported. Direct measurements of natural ball lightning. In January 2014, scientists from Northwest Normal University in Lanzhou, China, published the results of recordings made in July 2012 of the optical spectrum of what was thought to be natural ball lightning made during the study of ordinary cloud-ground lightning on China's Qinghai Plateau. At a distance of 900 am, a total of 1.64 seconds of digital video of the ball lightning and its spectrum was made, from the formation of the ball lightning after the ordinary lightning struck the ground, up to the optical decay of the phenomenon. Additional video was recorded by a high-speed camera, which captured only the last 0.78 seconds of the event, due to its limited recording capacity. Both cameras were equipped with slitless spectrographs. The researchers detected emission lines of neutral atomic silicon, calcium, iron, nitrogen and oxygen in contrast with mainly ionized nitrogen emission lines in the spectrum of the parent lightning. The ball lightning traveled horizontally across the video frame at an average speed equivalent of 8.6 ams. Oscillations in the light intensity and in the oxygen and nitrogen emission at a frequency of 100 Hz, possibly caused by the electromagnetic field of the 50 Hz high-voltage power transmission line in the vicinity, were observed. From the spectrum, the temperature of the ball lightning was assessed as being lower than the temperature of the parent lightning. The observed data are consistent with vaporization of soil as well as with ball lightning's sensitivity to electric fields. Laboratory experiments. Scientists have long attempted to produce ball lightning in laboratory experiments. While some experiments have produced effects that are visually similar to reports of natural ball lightning, it has not yet been determined whether there is any relation. Nikola Tesla reportedly could artificially produce 1.5 Euro-cubed balls and conducted some demonstrations of his ability, but he was truly interested in high voltages and powers, and remote transmission of power, so the balls he made were just a curiosity. The International Committee on Ball Lightning holds regular symposia on the subject. A related group uses the generic name unconventional plasmas. The last ICBL symposium was tentatively scheduled for July 2012 in San Marcos, Texas but was cancelled due to a lack of submitted abstracts. Wave-guided microwaves. Otsuki and Ufurigen described producing a Euro-OE plasma fireballs by microwave interference within an air-filled cylindrical cavity fed by a rectangular waveguide using a 2.45 GHz, 5 kW microwave oscillator. Water discharge experiments. Some scientific groups, including the Max Planck Institute, have reportedly produced a ball lightning type effect by discharging a high-voltage capacitor in a tank of water. Home microwave oven experiments. Many modern experiments involve using a microwave oven to produce small rising glowing balls, often referred to as plasma balls. Generally, the experiments are conducted by placing a liter or recently extinguished match or other small object in a microwave oven. The burnt portion of the object flares up into a large ball of fire, while plasma balls float near the oven chamber ceiling. Some experiments describe covering the match with an inverted glass jar, which contains both the flame and the balls so that they don't damage the chamber walls. Experiments by Eli Jerby and Vladimir Dikhtyar in Israel revealed that microwave plasma balls are made up of nanoparticles with an average radius of 25 nm. The Israeli team demonstrated the phenomenon with copper, salts, water and carbon. Silicon experiments. Experiments in 2007 involved shocking silicon wafers with electricity, which vaporizes the silicon and induces oxidation in the vapors. The visual effect can be described as small glowing, sparkling orbs that roll around a surface. Two Brazilian scientists, Antonio Pava-Pando and Gerson Pava of the Federal University of Pernambuco have reportedly consistently made small long-lasting balls using this method. These experiments stemmed from the theory that ball lightning is actually oxidized silicon vapors. Proposed scientific explanations: there is at present no widely accepted explanation for ball lightning. Several hypotheses have been advanced since the phenomenon was brought into the scientific realm by the English physician and electrical researcher William Snow Harris in 1843, and French Academy scientist François Section-Noir Arago in 1855. Vaporized silicon hypothesis: this hypothesis suggests that ball lightning consists of vaporized silicon burning through oxidation. Lightning striking Earth's soil could vaporize the silica contained within it, and somehow separate the oxygen from the silicon dioxide, turning it into pure silicon vapor. As it cools, the silicon could condense into a floating aerosol, bound by its charge, glowing due to the heat of silicon recombining with oxygen. An experimental investigation of this effect, published in 2007, reported producing luminous balls with lifetime in the order of seconds by evaporating pure silicon with an electric arc. Videos and spectrographs of this experiment have been made available. This hypothesis got significant supportive data in 2014, when the first ever recorded spectra of natural ball lightning were published. The theorized forms of silicon storage in soil include nanoparticles of C, CO, and SiC. Electrically charged solid core model: in this model ball lightning is assumed to have a solid, positively charged core. According to this underlying assumption, the core is surrounded by a thin electron layer with a charge nearly equal in magnitude to that of the core. A vacuum exists between the core and the electron layer containing an intense electromagnetic field, which is reflected and guided by the electron layer. The microwave EM field applies a Poindexter motive force to the electrons, preventing them from falling into the core. Microwave cavity hypothesis: Piotr Kapitsa proposed that ball lightning is a glow discharge driven by microwave radiation that is guided to the ball along lines of ionized air from lightning clouds where it is produced. The ball serves as a resonant microwave cavity, automatically adjusting its radius to the wavelength of the microwave radiation so that resonance is maintained. The Handel-Maser-Soliton theory of ball lightning hypothesizes that the energy source generating the ball lightning is a large atmospheric maser. The ball lightning appears as a plasma caviton at the antinodal plane of the microwave radiation from the maser. Soliton hypothesis: Julio Rubinstein, David Finkelstein, and James R. Powell proposed that ball lightning is a detached St. Elmo's fire. St. Elmo's fire arises when a sharp conductor, such as a ship's mast, amplifies the atmospheric electric field to breakdown. For a globe the amplification factor is 3. A free ball of ionized air can amplify the ambient field this much by its own conductivity. When this maintains the ionization, the ball is then a soliton in the flow of atmospheric electricity. Powell's kinetic theory calculation found that the ball size is set by the second Townsend coefficient near breakdown. Wandering glow discharges are found to occur within certain industrial microwave ovens and continue to glow for several seconds after power is shut off. Arcs drawn from high-power low-voltage microwave generators also are found to exhibit afterglow. Powell measured their spectra, and found that the afterglow comes mostly from metastable NO ions, which are long-lived at low temperatures. It occurred in air and in nitrous oxide, which possess such metastable ions, and not in atmospheres of argon, carbon dioxide, or helium, which do not. Hydrodynamic vortex ring antisymmetry. Physicist Demokos Tar suggested the following theory for ball lightning formation based on his ball lightning observation. Lightning strikes perpendicular to the ground, and thunder follows immediately at supersonic speed in the form of shock waves that form an invisible aerodynamic turbulence ring horizontal to the ground. Around the ring, over and under pressure systems rotate the vortex around a circular axis in the cross-section of the torus. At the same time, the ring expands concentrically parallel to the ground at low speed. In an open space, the vortex fades and finally disappears. If the vortex's expansion is obstructed, and symmetry is broken, the vortex breaks into cyclical form. Still invisible, and due to the central and surface tension forces, it shrinks to an intermediate state of a cylinder, and finally into a ball. The resulting transformation subsequently becomes visible once the energy is concentrated into the final spherical stage. The ball lightning has the same rotational axis as the rotating cylinder. As the vortex has a much smaller vector of energy compared to the overall energy of the reactant sonic shock wave, its vector is likely fractional to the overall reaction. The vortex, during contraction, gives the majority of its energy to form the ball lightning, achieving nominal energy loss. In some observations, the ball lightning appeared to have an extremely high energy concentration, but this phenomenon hasn't been adequately verified. The present theory concerns only the low-energy lightning ball form, with centripetal forces and surface tension. The visibility of the ball lightning can be associated with electroluminescence, a direct result of the triboelectric effect from materials within the area of the reaction. Static discharge from the cylindrical stage imply the existence of contact electrification within the object. The direction of the discharges indicate the cylinder's rotation, and resulting rotational axis of the ball lightning in accordance to the law of laminar flow. If the ball came from the channel, it would have rotate in the opposite direction. One theory that may account for the wide spectrum of observational evidence is the idea of combustion inside the low-velocity region of spherical vortex breakdown of a natural vortex. Nanobattery hypothesis. Oleg Meshtriakov suggests that ball lightning is made of composite nano or submicrometer particles, each particle constituting a battery. A surface discharge shorts these batteries, causing a current that forms the ball. His model is described as an aerosol model that explains all the observable properties and processes of ball lightning. Black hole hypothesis. Another hypothesis is that some ball lightning is the passage of microscopic primordial black holes through the Earth's atmosphere. This possibility was mentioned parenthetically by Leo Vuk in 1992 in a patent application and a second patent application in 1996 by Lendit Vuk. The first detailed scientific analysis was published by Mario Rabinowitz in Astrophysics and Space Science Journal in 1999. It was inspired by M. Fitzgerald, unregistered trademark S account of ball lightning on August 6, 1868, in Ireland that lasted 20 minutes and left a 6-meter square hole, a 90-meter-long trench, a second trench 25 meters long, and a small cave in the peat bog. Pace van der Vende, a plasma physicist at Sandia National Laboratories in Albuquerque, New Mexico, and his team found depressions consistent with Fitzgerald unregistered trademark S report and inferred that the evidence is inconsistent with thermal and electrostatic effects. An electromagnetically levitated, compact mass of over 20,000 kg would produce the reported effects but requires a density of more than 2,000 times the density of gold, which implies a miniature black hole. He and his team found a second event in the peat bog witness plate from 1982 and are trying to geolocate electromagnetic emission consistent with the hypothesis. His colleagues at the institute agreed that, implausible though the hypothesis seemed, it was worthy of their attention. Buoyant plasma hypothesis. The declassified Project Condign report concludes that buoyant charged plasma formations similar to ball lightning are formed by novel physical, electrical, and magnetic phenomena, and that these charged plasmas are capable of being transported at enormous speeds under the influence and balance of electrical charges in the atmosphere. These plasmas appear to originate due to more than one set of weather and electrically charged conditions, the scientific rationale for which is incomplete or not fully understood. One suggestion is the meteors breaking up in the atmosphere and forming charged plasmas as opposed to burning completely or impacting as meteorites could explain some instances of the phenomena, in addition to other unknown atmospheric events. Transcranial magnetic stimulation. Corey and Corey stated that the features of hallucinations experienced by patients having epileptic seizures in the occipital lobe are similar to the observed features of ball lightning. The study also showed that the rapidly changing magnetic field of a close lightning flash is strong enough to excite the neurons in the brain. This strengthens the possibility of lightning-induced seizure in the occipital lobe of a person close to a lightning strike, establishing the connection between epileptic hallucination mimicking ball lightning and thunderstorms. More recent research with transcranial magnetic stimulation has been shown to give the same hallucination results in the laboratory, and these conditions have been shown to occur in nature near lightning strikes. This hypothesis fails to explain observed physical damage caused by ball lightning or simultaneous observation by multiple witnesses. Theoretical calculations from University of Innsbruck researchers suggest that the magnetic fields involved in certain types of lightning strikes could potentially induce visual hallucinations resembling ball lightning. Such fields, which are found within close distances to a point in which multiple lightning strikes have occurred over a few seconds, can directly cause the neurons in the visual cortex to fire, resulting in magnetophosphenes. Spinning plasma toroid. Swid proposes that ball lightning is a spinning plasma toroid or ring. He built a lab that produces lightning-level arcs, and by modifying the conditions he produced bright, small balls that mimic ball lightning and persist in atmosphere after the arc ends. Using a high-speed camera he was able to show that the bright balls were spinning plasma toroids. Chen was able to derive the physics and found that there is a class of plasma toroids that remain stable with or without an external magnetic containment, a new plasma configuration unlike anything reported elsewhere. Swid published images of the results of his experiments, along with his method. Included is a report by a farmer of observing a ball lightning event forming in a kitchen and the effects it caused as it moved around the kitchen. This is the only eyewitness account of ball lightning forming, then staying in one area, then ending that the author has heard of. Rydberg matter concept. Manikin et al. Have suggested atmospheric Rydberg matter as an explanation of ball lightning phenomena. Rydberg matter is a condensed form of highly excited atoms in many aspects similar to electron-hole droplets in semiconductors. However, in contrast to electron-hole droplets, Rydberg matter has an extended lifetime as long as ours. This condensed excited state of matter is supported by experiments, mainly of a group led by Homelid. It is similar to a liquid or solid state of matter with extremely low density. Lumps of atmospheric Rydberg matter can result from condensation of highly excited atoms that form by atmospheric electrical phenomena, mainly due to linear lightning. Stimulated decay of Rydberg matter clouds can, however, take the form of an avalanche, and so appear as an explosion. Other hypotheses. Several other hypotheses have been proposed to explain ball lightning, spinning electric dipole hypothesis. A 1976 article by V.G. Endian postulated that ball lightning could be described as an electric field vector spinning in the microwave frequency region. Electrostatic Leyden jar models. Stanley Singer discussed this type of hypothesis and suggested that the electrical recombination time would be too short for the ball lightning lifetimes often reported. J. Pace van der Vende separates extreme ball lightning of the highly energetic violent kind, and proposes a theory of neutrinos and heavy neutrinos. Smnov proposed a fractal aerogel hypothesis. V. P. Torshishin proposed considering ball lightning as a form of self-confined intense light. M. I. Zelikin proposed an explanation based on the hypothesis of plasma superconductivity. Penthouse M. Papaoulias studied the antimatter meteor hypothesis as a possible explanation of ball lightning formation. He compared all properties of ball lightning to those expected by an antimatter meteor undergoing annihilation by atmospheric molecules and found almost identical properties. See also. Notes. Further reading, Barry, James Dale. Ball lightning and bead lightning. New York, Plenum Press. ISBN A0-306-40272-6. Cade, Cecil Maxwell. Delphine Davis. The Taming of the Thunderbolts. New York, Abelard Schumann Limited. ISBN A0-200-71531-3. Coleman, Peter F. Great Balls of Therea. A Unified Theory of Ball Lightning, UFOs, Tunguska and Other Anomalous Lights. Christchurch, NZ, Fireshine Press. ISBN A1-4116-1276-0. Coleman, P.F. 2006, JSCIEXPL, Volume 20, No. 2, 215 €238. Golder, R. H. Lightning. Bristol, John Wright & Sons Limited. ISBN A0-12-287802-7 Golder, R. H. Lightning Volume 1 Physics of Lightning. Academic Presser, Sword, Clint, Ball Lightning Explanation Leading to Clean Energy, ISBN 978-1-4583-7373-1 Amazon.com, Stenhoff, Mark. Ball lightning, an unsolved problem in atmospheric physics. Kluwer Academic Plenum Publishers. ISBN A0-306-46150-1 Uman, Martin A. Lightning. Dover Publications. ISBN A0-486-25237 Exer, Vemaster, Peter E. The Lightning Book. Cambridge, MIT Press. ISBN A0-262-22017-2. External links, a video of a microwave plasma ball experiment, abstracts of papers of 2010 AIS conference in Kaliningrad, Russia, a statistical study of ball lightning events observed in France between 1994 and 2011.